Today we'll be hearing from, unfortunately, just Jason Stephanoutos, our Global Decarbonization Director. Lefteris Kokolopoulos, unfortunately, is not feeling well, but he will be here for the Q&A. And of course, there's me as your host. Now, one more thing before we get started, let's have a quick run through of today's agenda. We'll be looking today at industry drivers and decarbonisation options, why energy efficiency is so important. We'll be having a look at the practice of energy efficiency, the technologies there, and how we can plan ahead to maximise energy efficiency. Then we'll have our Q&A session. And so, without any further ado, I'll hand over to Jason.
Thank you. Thank you, Simon. Good morning and good afternoon to everyone. Thank you for joining. As Simon said, I will now take over to guide you through our webinar and our energy efficiency publication. So before I start, I would like to mention, as Simon said, that we were supposed to be two presenters, but the second one had a technical issue. He has no voice, so I will take through that, but we will both do the Q&A session. And before I go into the main part, I would like to say that all the reason why we have today's webinar and all the material is based on a publication that DNV released 2 weeks ago. You can find it here either by scanning the QR code or clicking on the link in the material you will receive. It is a quite extensive presentation, publication covering more than 40 measures, providing both the overview, but also more detailed information around specific measures and technologies. So starting on why we talk about energy efficiency, we need to take a step back and see the drivers of decarbonization. So why do we care about decarbonization in the shipping industry? And the first drivers that set the wheels in motion come from the regulatory frameworks. Last year was a milestone year. We had the first CO2 tax being applied through ETS. This year, it's being augmented with Fuel EU. We expect to see in a few weeks what IMO will decide on that front as well. But what we see so far is that with today's levels of cost, of emissions cost, there is no huge incentive in pushing large investments. There is a driver, but it's not the biggest one. We see the commercial drivers being the dominant ones. If you search all the big investments behind fuels and energy efficiency, you will find a cargo owner or a charterer being connected to that. And of course, last but not least, we have financiers, we have the financial institutions that more and more become interested in emissions performance of their lending assets. We had Poseidon Principles. We have a lot of financial institutions focusing on emissions and connecting it to their lending schemes. And what can we do? There are many things to do. If we try to structure them, there are 4 main categories. We have the low and the zero carbon fuels. They will be the most important part of the end solution, and they require an industry-wide energy transition, which has already started. We see more and more vessels going that way, but it will take some time, and it needs a lot of all the stakeholders across the value chain to be enabled, including not only ship owners and shipyards, but also fuel producers and fuel suppliers. Then we have biofuels, which are drop-in fuels, very easy to use. And they require minimal to no further investment, but they have challenges with availability and price. Today, they pose the most popular solution for achieving compliance with Fuel EU. Then we have energy efficiency and technology. The industry has a lot of experience around those for many decades. And now we live in a period of abundance of innovation around these technologies, many new technologies being developed, many new concepts being tested. And this is what creates the need for validating the performance and the actual savings of this technology. And last, we have the operational measures. They can be low-hanging fruit, but it's not always within the operator's reach. Sometimes other stakeholders like ports and charterers need to take actions. So starting from the fuels, what we see here, if we start from the left-hand side with the pie charts, we see in the top left-hand side, we have the uptake of alternative fuels. In the existing fleet, it's more than 8% of the existing fleet is able to burn some alternative fuel. We don't talk about fuel-ready vessels, we talk about fuel-capable vessels. And 8% is a lot, but not big enough. So it will become bigger in the future. If you see at the bottom left, more than half of the existing order book is going to be capable to burn alternative fuels. So we expect the uptake and the theoretical demand to increase. So this is one aspect of the story. If we take a second one, we go to the supply. We will have some part of the fleet being able to burn those fuels, but will they be available? And on that front, we see that there is a lot of activity, many projects that are being discussed and agreed. We have our AFI database that we can have a quite good forecast on where this is heading. But the big challenge here is how much of these fuels will be available for marine usage, both in terms of geographical availability, but also in terms of cost. And the last aspect of this story is the actual fuel demand. So we have the theoretical capacity, the uptake, how much the fleet can burn. We have the supply, how much fuel is available, and then we have how much fuel is actually burned. And this amount has been growing, but it remains quite uncertain for the future. The fact, and the definite fact, is that we can reduce that by utilizing energy efficiency measures, and this can help in the long term. So this leads us to the question, why is energy efficiency important and how can it help? It can help in multiple ways. When it comes to the short term, it helps and has been helping for many years with reducing consumption, which relates to costs, both fuel costs, but also emission costs, since now we face CO2 taxes, and can help with compliance, either directly or indirectly. But this is the short term. If we take the long term and we see more futuristic approach, we see that energy efficiency can be a great enabler of faster adoption of alternative fuels. How? We have two main arguments to substantiate that. One is this comes from our maritime forecast studies, where we estimated a potential improvement through energy efficiency for the global fleet of 16%. And this is quite a big number, but to bring some context into it, it is the same amount of emissions that would be emitted from the 2,500 largest ships of the global fleet, or 55,000 of the smallest ships, which is, both are quite big numbers and show how much good potential energy efficiency shows. Of course, not the entirety of this 16% can be achieved, and especially due to not having a good business case and techno-economic results. But the interesting part of this is that all these 16% in theory and technically can be achieved with today's technology. So it's not something that we need to develop new infrastructure or new technologies or new on-land production facilities, but we can utilize it today with today's technology. But of course, it does not always make financial sense. But then we have another example. If we take this Cape-size bulk carrier traveling between Brazil and Europe, today she would burn 600 tons for this one voyage, paying $300,000. If we now take a theoretical increase of energy efficiency by 20%, that would mean that for each voyage we could save $60,000, which is quite a good payback and can provide some positive business cases for a few vessels, for quite a few vessels. But then in the future, we may not necessarily, we cannot necessarily predict the fuel of the future, but we can say with quite high confidence that it will be quite more expensive. And in this reality, the savings from each trip multiply. And in this case, it could reach up to $300,000. And this can make the business case quite different in both ways, both for adopting energy efficiency more easily, but also if you adopt energy efficiency, you can then adopt the fuels quite more easily because it will reduce the cost, which is one of the biggest challenges with the new fuels. And this amount does not even include the savings from the emissions cost decrease through achieving compliance. So at this point, I would pass it over to Simon to have our first poll.
Thanks a lot, Jason. Right now, we'd like to hear a little bit from you. If we can pull up our poll questions now. We seem to have a little bit of, here we go. And we'd really like to know a little bit about your business's incentive for investing in energy efficiency. What's the prime motivation for your company to make investments in energy efficiency? Is this improving regulatory compliance? Is it a cost saving over the short or long term? Is it something that's requested or expected from you by charterers? Is it simply out of the impulse to do something, or if the question's not applicable to you, there's the bottom option there. So we'll give you a little a minute there to weigh in. And then we'll tabulate the results. Right, so Jason, looks like, once again, it looks like a very heavy emphasis there on long and short-term cost saving, with some also regulatory compliance coming in there from those who answered. So what do you make of those results? Are they in line with what we're seeing?
I think so, yeah, especially this, the biggest part, 45% cost savings and short long term. But I'm also intrigued by the I don't know yet, the 20%, which shows some uncertainty. And definitely this is something that resonates with our understanding of the industry. There is a lot of uncertainty. We will cover that in the next slides, but definitely it's something that we as an industry can work on. And yeah, okay, so that was interesting. Now moving on, going a bit more practical on the energy efficiency to see what are the various solutions and how can they be applied. So in the industry, we have quite a lot of experience when it comes to energy efficiency. In our report, we try to merge them in 5 big categories. We have operational measures, measures focused on propulsion and hull and machinery. These are the more traditional ones. And then we have some more, let's say, new ones that cover energy consumers and energy harvesting. And as I said in the beginning, although the industry has quite an extensive experience around the technology and the energy efficiency technology, both applying and studying it, we now face a renaissance of development. We see many makers, many institutions, many research facilities going for developing new technology. And this is good because it can provide us with more solutions, more technology, but it also creates uncertainty. And I think I would connect that with the uncertainty that we found in the poll, that in order to decide going forward, you need to have more solid arguments, you need to have more solid information. And this is where we see the need in the industry to have more sophisticated ways of assessment and verifying the saving claims. This is also reflected to the uptake. We have here some statistics, high-level statistics on the uptake of the technologies. We should not fixate on the numbers because in any case they're hard to estimate, so I would not fixate on the numbers, but I would like to focus on the trends. And you see, first of all, the first key takeaway for me from this table is that you have a lot of greens and a lot of reds. So there are technologies and there are ship types that have very low uptake of energy efficiency. In contrast, this means that they have a lot of potential. And then you have other segments like the container ships, for example, that have been doing a lot of retrofitting and a lot of installation in new buildings, and they have high uptake. But even if you go to the greenest parts, you see that the percentages are quite low. And this shows that we still, as an industry, have a lot of potential. But of course, it does not always make sense to go for the retrofitting route. In order to assess, you need to assess on a vessel, on a case-by-case vessel specific basis, and take into account all the parameters in order to assess the feasibility of the retrofit. In this report that we published, we have monitored all the available technologies, more than 40 measures, and you can find this table that has a very high-level presentation of all the technologies, providing information on some metrics, including efficiency gains, costs, but also information on the implementation time. Then information on the impact, on which schemes can this technology be used, EEDI or only operational measures like schemes like CII or FuelEU, and then a very high level applicability on ship types. So of course this can vary significantly within one segment. You have various sizes of tankers, and even in the same size you have various operating conditions, but this provides a good overview of where should you focus. Now, if you want to focus on one technology, in the report for each technology, we have 1 or 2 pages that that provide information on the main challenges, the main dimensions, class requirements, milestone projects, industry experience, and also they have this ribbon that you can very easily guide yourself through the suitability of this measure on specific vessels. So this ribbon covers the TRL, the technology readiness level of the technology, of the measure, and then in the bottom you have the ship type, the vessel type suitability for each ship type and size, how suitable this is based on our experts' judgment opinion, taking into account all aspects, both technical, operational, and commercial and techno-economic aspects. Then you may get information on the vessel age applicability. It may be that the older the vessel gets, the less promising this technology becomes, typically from techno-economic point of view. And if this is a good option to retrofit or if it only focuses on new building installation. Then in which schemes does this have an impact on? EXI, EEDI, CII, ETS, and FuelEU or GFI, with a disclaimer here that we don't know, but based on the latest drafts of how the GFI could look like. And in the last column, you may find some high-level information around the CAPEX, the efficiency gains, the OPEX, but also implementation information. And as I said previously, this is quite high level. For more details, please come in contact with us and our experts and your local point of contact to get more information on the specific vessels and routes. So now trying to go through the main categories of the technology, of the energy efficiency technology, we have propulsion and hull measures. We have 4 aspects that we judge each category: technology, regulatory acceptance, efficiency gains, and economics. When it comes to technology, this category of measures is quite mature. However, we see quite many new technologies being developed every month. And when it comes to regulatory acceptance, it's quite high and relatively easy. They can provide efficiency gains across the whole spectrum from low to high. The higher you go, the bigger, the more time-consuming installations you need, but also the higher the investment cost is. And when it comes to economics, we have typically low returns, ROIs, returns on investment. The 3 most popular measures that we see on this category is propeller retrofit, typically mainly done for container ships, but can provide quite a lot of savings. Low friction coating, I think that's one of the most popular solutions overall, and the past year it has been boosted quite significantly. And propeller flow improvements that can be retrofitted quite easily. Some of them do not even require dry dock to be responded. Then we have machinery measures. They are quite mature. The interesting thing here is that we see old technologies that did not make sense for financial, techno-economical reasons. Now they do make sense, so they come back. There is high regulatory acceptance, and the efficiency gains can be low to medium typically, which leads to higher ROIs. The most popular solutions are shaft generators that become also a standard in new buildings, waste heat recovery, and both high temperature and also ORC, but they can be costly, a costly retrofit. And finally, auxiliary engines economizer, that is a very common choice for new buildings. Then we have the more exotic stuff, new stuff, energy harvesting. These are quite novel technologies that need to be proven. Definitely, when it comes to regulatory acceptance, they have especially wind-assisted propulsion. They have this reward that FuelEU provides, the 5%, and they have also. There are discussions that IMO will add something similar, so it's quite good on the regulatory aspect. When it comes to efficiency gains, they are quite ship-specific and actually route-specific. Especially wind is the gains and the business case of installing any type of WAPs is heavily connected with the weather profile of the route of the vessel. So automatically this excludes large part of the fleet, but if it can be predicted for specific routes, then there are quite high gains that can be achieved. And definitely they are quite costly exercises, at least for now. The capex is quite high, but of course the more we go into a volume business, we expect the cost to reduce significantly. And last but not least, we have the operational measures. They are mature, but the challenge here is that it's not always within the control of the operator, of the owner or the manager. They are de facto accepted by the regulations because they have an impact on the actual consumption, and they can provide up to moderate efficiency gains. The most popular ones being discussed is just-in-time arrival, also needing the cooperation of other stakeholders, hull cleaning, and autopilot. So now trying to focus on a few selected technologies, but before we go there, I would like to also set some focus on this table that you can find in our report that shows which technologies go well together and which do not. So the light green shows technologies that are mainly irrelevant to each other. The dark green are technologies that enhance each other and should be considered to be installed together. The purple ones, the orange ones are technologies that should be studied before being both installed, because one could cancel the other, and the red shows technologies that cannot be installed together. So we have a few examples. if a vessel is about to install an ALS, air lubrication system, then of course there are synergies with shaft generator. Being able to produce the extra power needed with better efficiency creates a very good synergy. But on the other hand, this could limit the impact of the ALS if you have a dead weight increase, because it may affect the efficiency of the whole system. And similar, if you have high performance coating, then you will not get the savings of both, because inherently ALS provides better anti-fouling capabilities. Another example is batteries. Of course, they go very well with solar. You have this periodicity of solar panels, so if you can store the energy and use it when you need it, and when your energy production is expensive, then it's quite a good synergy. And then another example has to do with the exhaust gas boilers for auxiliary engines, which is a quite common technology used, but this needs to be studied when it is combined with a shaft generator, because already you're limiting the use of auxiliary engines, and you need to see if overall the economics makes sense, or even more if you rely on shore power. So focusing on a few selected technologies now, we have energy efficiency lighting systems. They are quite an easy retrofit. It can be high cost for some vessels, but also high reward. For cargo vessels, it may not have that big of an impact, but for other ship types like cruise vessels, ROPAX and PCTCs, it can be quite rewarding and impactful. And when it comes to the ribbon, which again you may find in the report, this is being reflected here as well. It's irrelevant to the age and can significantly help with CII and ETS. It's a small percentage, but it's quite easy to achieve. Then we have VFDs, variable frequency drives. In a nutshell, they replace the standard drives with a dynamic power adjustment, so you don't work between 1 and 0, but you can work at the load that you need the motor to work, and this can provide quite significant savings. Where can it be applied? There are quite a few systems on board the vessel that VFDs can be applied. Most commonly, they're used for the engine room fans and the large compressors that may be found in the engine rooms and cooling water pumps. But then there are applications also for less common application for ballast pumps and steering gear pumps as well. There is a lot of experience from the industry. There have been many retrofit projects so far, and in new buildings, we can safely say that it is considered a standard. And of course, this applies to all vessels and all ages. Again, this is a quite straightforward retrofit to do and does not even take that much time, but definitely it will require some time, either during the dry dock or sometimes even a port stay. Then when it comes to wind-assisted propulsion systems, the WAPS, we touched on that already, but I think we can focus a bit more on that, because last year was an exceptional year for WAPS. We reached almost 100 applications already on real vessels, and it is quite an interesting technology. It can definitely not be applied to all, but it can provide significant gains. Pixie's Ocean, the vessel that got a lot of media attention, that had the rigid sails, she was able to sail at 5.5 knots only on wind without main engine usage, which is quite interesting. The challenge with WAPS is first of all to have a good weather profile. You need to know where the vessel will trade, and that this trade will have a good wind profile to be favorable for wind. In a nutshell, you cannot get many savings if there is no wind. So this needs to be studied. On the other hand, FuelEU has provided a 5% reward. So just by having installed WAPs on board the vessel, a 5% compliance is already achieved, which is a quite big incentive, especially for vessels with high consumption and high activity in EU ports. And from our statistics, what we see is that almost half of the installations have to do with rotor sails. Then we have suction wind and wind sails. But of course, there are various technologies, and each one has pros and cons, and you need to study which one is best for your specific vessel. And as we touched already, this is not a cheap exercise. It's quite costly, but of course the efficiency gains can potentially be quite high. But definitely there is a challenge to find a good positive business case for a big part of the fleet. Then we have another big large investment solution, ALS, air lubrication systems. In a nutshell, it's reducing the hull friction by inducing bubbles under the hull. As one may think, it's the savings are connected very much on the hull geometry and hull specifications, and it can provide savings, but for some vessels it may not provide any savings. There is an additional benefit that the existence of the bubbles may prevent marine growth on the hull. And this is the reason why if you have ALS and a very high performance coating, you need to make a study to see that one does not cancel out the savings of the other. The cost can be low to high depending on the technology and can be applied in quite some vessels, mainly on the mainly depending on the hull geometry. When it comes to exhaust gas boilers on auxiliary engines, this is quite a popular solution. It helps a lot, especially during the operations at port and during anchorage. Sometimes it can even eliminate, but typically minimize the usage of the auxiliary boiler, and this can have a significant fuel consumption, an impact on the fuel consumption. But of course, now that we see the rise of the shaft generators, we need to study if both of them make sense, because having a shaft generator would mean that you use the auxiliary engines less. So the overall techno-economic analysis needs to take into account that both technologies may cancel each other out. And it can be applied to most vessels. Typically for newer vessels, does not make sense to retrofit a very old vessel. It is possible technically, but not financially, and it can be done during normal dry dock. Shaft generator is the other usual suspect. It's been becoming quite typical especially for new buildings. In a nutshell, it can provide electricity production at a much higher energy fuel efficiency compared to the auxiliary engines because of volume, and also it has a very good synergy with air lubrication exactly for the same reason. So air lubrication requires an additional amount of power to operate, and producing this energy with a much better efficiency can create a much better efficiency for the overall system. It applies to most of the ship types and sizes. Again, it can be retrofitted, but the older the vessel, the less it makes sense, and can be applied within and can be installed and retrofitted during normal dry dock. Another quite interesting technology is shore power. It has received a lot of interest and traction because of some regional requirements. There is also an EU requirement that will demand from container ships and cruise ships to have shore power usage. The penalty of not complying is quite high, and this has been pushing this technology a lot in the industry. From our side, we did a study in our maritime forecast study last year. We estimated that there is a 7% of the global emissions are attributed to operations at port. So, and of course, this is very segment specific. We have segments like the cruise vessels that can go up 15%. And definitely we cannot replace all these emissions with the energy produced emitting these emissions. We cannot be replaced by shore power. But even if we can achieve half of that, that's still quite a big achievement. It can be applied to many ship types. Now it makes more sense for cruise vessels and container ships. They have a large port consumptions and port stays. It is irrelevant to the vessel age. It's not something that cannot be technically applied. Financially, it not make that big sense. But the biggest challenge when it comes to shore power has to do with the ports, because when it comes to the vessels, there are some challenges, mainly around standardization, but at the end this will be solved, and already we have vessels that can very safely utilize shore power. But currently not all ports are prepared to deliver this green shore power in terms of infrastructure, in terms of cabling, in terms of ensuring that they have access to green shore power. So in order for this to really take off, other stakeholders and especially ports need to step up their game. Now in the report, for the sake of completeness, we have also information and high-level overview of other decarbonization solutions that go beyond energy efficiency. Starting from low carbon and carbon neutral fuels, we already touched on that. They have quite high uptake on new buildings, currently being more than half of the order book. But then the main challenges lie around availability and price. Similar for biofuels, they are the most popular solution for FuelEU, achieving compliance. They are in theory, the best decarbonization solution. You do minimal to no retrofit, you pay a premium and you are compliant, but as many things, it's too good to be true. And I need to quote a colleague saying that this could be quite a lazy solution because you achieve short-term compliance, but you don't plan for the future. So our view always is that, yes, use biofuel to achieve compliance today, but as its availability may be challenging in the future, make sure that you plan ahead also for other solutions and you don't just rely on biofuels. Then we have onboard carbon capture and fuel cells. They are quite promising technologies. Still, we need to do a lot of work in order to have mass production and being considered widely mature technologies. And then we have nuclear that is definitely away from being a mature technology, but it is most probably going to play a big part of the long-term energy mix. And it may be we don't see onboard usage in the next years, but definitely it can be used for floating energy production or even producing the green fuels that the industry needs. Definitely from our side as DNV, we have been quite active on the nuclear propulsion. We don't, and for any technology, we don't promote or demote any technologies, but we need to be ready to assess these technologies from the class perspective. So that's about the technology. Now let's see how to bring this into context. And first of all, we saw that the technology is there. There is a lot of knowledge in the industry, but we don't have that much of an uptake. And as I think we can interpret partially the poll outcome, there is a lot of uncertainty. And although we may have the theoretical understanding of how technology works, we still do not have large, big confidence on the saving gains as an industry. And of course, it makes sense since we have a lot of new technologies. And this is where we say that we need new verification standards by the industry. And we have been quite active on that front. We have released a recommended practice on the technical ship performance, the VTI, the Vessel Technical Index. We have been providing to open hearing recommended practices on ALS and WAPS. And as general guidance, we see three pillars that we need to improve as an industry. First of all, data. This is the quintessential part of this equation. We need to have good quality data, and this can only be achieved through standardization of the data acquisition processes. Now we see a very vast domain of different quality, different levels, and different ways to acquire data and to manage data. Then the second step is methodology. We need to make sure that we use science-based assessment methodologies to properly isolate the actual effect and to get the actual savings of the technology and not the effects around it or the weather. And last but not least, we need to make sure that we aggregate these savings and the results to the actual operation of the vessel. It's very often the case that we find savings in one design spot that mainly is not even the most frequent operational point of the vessel. So you may have 20% savings in one combination of speed and load and laden condition, and then the vessel sails only 3% of her time at that condition, and the rest is 3 to 5. So we need to make sure that we annualize the savings to the actual operating profile of the vessel. And then it's not only a matter of having the knowledge on the technology, but also planning. And what we suggest and what we have been supporting the industry with is to plan ahead, to have a decarbonization plan, to make sure that you have assessed the fleet and you have provided a list of what technologies potential for each fleet, and then you have a very solid implementation plan. And we need to stress this last part because we very frequently see companies, they invest and they do, and we help a lot of them to develop a plan on how to implement the energy efficiency on a fleet-wide approach. But then when it comes to actually implementing, many parameters affect it and it's not being materialized. People leaving and not having a succession plan, not having the proper monitoring process or the KPIs. And this is something that we always stress needs to be in line when you have a decarbonization plan. So at this point and before closing, I will pass it over again to Simon for our second and last poll of this webinar.
Thanks. So once again, we'd like to hear your take on some of the measures that we've been discussing today, and which of those measures do you think are the most relevant for you to invest in? We've got the operational measures like speed optimization, increasing the draft, or using weather routing technology, measures involving the propulsion and hull, propellers, or ducting, coating, air lubrication systems, or a change to the shape of the bow, measures around the machinery, the engine in particular, waste heat recovery, shaft generators, something around energy harvesting. We've got sort of wind there. I guess solar panels might be also included in that option. And then finally on energy consumers, cargo handling options, and others of that nature. So we'll give you a little bit to offer your thoughts on the different types of measures.
It's interesting. I think we have, we have a quite clear image with 40% being voted. So yeah, propulsion and hull and operational measures are on the top. It makes sense. Propulsion and hull and machinery are the most frequently used, the most traditional technologies that we see the industry has a lot of experience, and especially If you compare machinery and propulsion and hull, the latter is quite more easy and cost-effective to install. Interestingly, operational is on the top, which makes sense, especially when it comes to draft increase and weather routing. I think these are quite non-brainers for many segments. And I think it's quite promising that we see a 9% routing for energy harvesting and wind, which is quite an exotic technology, and we expect to see more and more from it. Great.
Indeed.
Okay. So, closing, and before we have our Q&A session, just to recap, we have been discussing a lot about energy efficiency, and we expect this will play a significant role. But starting from talking about not energy efficiency, we should always, I mean, from this study and this the various studies we have been doing and this publication per se, we have identified some recommendations for the industry. And we start by always saying you should always investigate new fuels for new buildings. It may be the case that it does not make sense for some ship types and sizes. It definitely does not make sense, but with the targets being set and the targets being quite close, we definitely should investigate all technologies and possibilities. So we should not rely on bias. We should not close the doors to technologies or fuels, and we should not aim for technologies or fuels without studying them. And this is why we say, even if for your ship type and size does not make sense to go for fuels, still make the investigation. And this can provide you the facts that you will not just have a biased opinion, but you will have a fact-based decision that I will not go for new fuels today, or I will go for new fuels based on this and that. And beyond that, when it comes to the energy efficiency per se, the first step is to assess the status of the vessel and the fleet. This is something that we see more and more companies have been doing. Of course, there are companies that have large departments and that have been actively doing that for years, but now we see an industry-wide focus on that. The next step, once you know your fleet, is to identify the options and the remaining potential, and then develop a fleet plan and implementation. And this, as I stressed just before the poll, we cannot stress enough the importance of the implementation plan. This is what will make theory a reality, and you need to make sure that you have the implementation plan, a solid implementation plan in place. And last but not least, data infrastructure and data acquisition, they play an increasingly important role. For many companies, this has been a strategic target for the next year. When MRV came, we had the first big infrastructure transition. Now we have FuelEU, and this becomes quite important for the emissions management. But also, since we go into a road that we invest in data infrastructure, it is critical to make it proper so we can actually get proper quality that will allow us to use this data for analytics. And in these uncertainty periods that we see more and more technology, having good quality data is key. Because let's say you have a new technology, you install it on board a vessel. If you have good quality and good processes and you analyze it and get good results, then it can significantly accelerate and make easier the decision-making process for the next of the fleet if you plan to implement it across the fleet. And I would close by saying that energy efficiency is an important aspect and works in parallel with alternative fuels. So they are two pieces of the same puzzle. One can enable the faster adoption of the other, and more specifically, energy efficiency can help faster adoption with the faster adoption of alternative fuels. So before closing, I would like to also draw your attention in our other recent publications. We have Maritime Forecast that goes live every year. FuelEU and onboard carbon capture were released last year. And just this year in January, we had biofuels and wind-assisted propulsion systems. So with this, I think we reached the end of our presentation, so we can safely go into the Q&A session.
I think we can too. Let's get into that right away because we have had a lot of questions, and I think it's always great to see what we can feedback. I think also, as Jason said, there's a lot of material online, including on our Decarbonization Hub, and also the report that you can download from the DNV website. So head there if you're interested in following up on any of these topics in a little more detail. Let's maybe start off with a very basic question around how we, I think maybe let's not go into too much detail, but what we've based the cost calculations on for some of the measures and the numbers in the report. If we could maybe have just a little detail on that.
Yeah, I mean, that's a very good question, and it's not easy to say, but the main part of all this information comes from our internal database. We have been doing projects on energy efficiency for quite a few years now, for decades, and we have gathered all this information in one database. So mainly this information comes from projects that DNV has directly been involved, and not just open literature that may be not verified. But of course, this is very dynamic, especially the cost element is something that is very volatile, both in terms of the maker side, the technology provider, and the volume increase and the mass production of technology, but also in terms of negotiation and the size of the project.
Yeah, absolutely. As we know, this is a very dynamic area that that changes a lot. But I think the trend is probably only in one direction. One series of questions or topics that many people have touched upon is maybe starting at the very basics around fuel itself and the impact that additives and sort of new changes to the fuel through use of different types of enzymes or different types of additives can actually have. I guess we're mainly talking about conventional fuel there rather than alternatives. But have we looked a lot at what sort of gains can be made there?
Yeah, they are not covered in the report because the challenge, I mean, there are many companies that provide these additives, but for the time being, we did not have a clear view on the actual performance of those, but definitely we are open to discuss more on those in terms of savings and performance.
Right. One of the things, of course, we see that is coming through that it's not just the ship owners themselves, but cargo owners and charterers who are pushing for energy efficiency and fuel savings. Could we maybe talk a little bit more about the positives that are coming sort of from outside the industry and how that's impacting the drive for energy efficiency?
The outside meaning? Sorry, I do not see the question.
I guess more cargo owners, financing, charterers themselves, the push there that is looking to reduce emissions.
Yeah, I think that's a main driver, if not the most dominant driver. I mean, along with regulatory aspects, we see a lot of cargo owners now, they have a lot of focus on ESG, but also on costs, and they both fuel costs and emissions costs, and they are very open to investigate, and they push actually to investigate for any technology usage. Of course, this is very relevant to the ship type and the cargo type. Not all commodity traders and cargo owners and charterers have the same focus, but we see some being quite active, and if you see most of the projects, especially, let's take WAPS, for example, which is a very big technology. It's big technology, high cost. You always have the cargo owners and the charterers being involved in most of the projects. You have them backing it up. And from our discussions with them as well, we see that there is a lot of interest to understand the technologies, to make sure that we have investigated everything and that we don't leave any stone unturned. And this also resonates with our key messages from the Maritime forecasts and in general as DNV position, that we need to make sure that we investigate any technology. We don't need to make our biased opinions that we forget about this technology or we promote this technology. In this uncertainty period, we need to make sure that we use facts to get more information and understanding. And based on these facts, we decide how to invest and how to move on.
We had quite a few questions around hull coatings and hull cleanings as an option, including some around underwater noise. Maybe we could talk a little bit more about the hull coatings and hull cleaning and I guess air lubrication as well as part of that.
Yeah, I mean, for coatings and cleaning, I don't see it being connected with noise. Definitely ALS could work on that. I do not have any more solid information. Whoever was the person asking this question, please come in contact with us and we can connect you with our expert. But as a general comment on those three technologies, I can say this have been quite popular. And we see all owners at least investigating those three measures, if not doing, because it can affect the biggest energy consumer, and improving the hull resistance is a key part of reducing fuel consumption and therefore emissions and costs. So it's been quite active. But as we said, we need to stress the fact that these technologies do not allow for complementary installation. So installing one may reduce the savings from the other. So you don't just go adding the savings. You have some canceling effects and you need to make sure that you study it properly before you invest.